This is another SudokuPrimer video. Go to SudokuPrimer.com for more Sudoku techniques. This is puzzle number 93. It's a diabolical puzzle from Sudoku To Go, Volume 100 by Soap Opera Digest. I've already solved an easy, medium, hard, and diabolical puzzle from this volume. But this one has kind of a special case that you don't see very often, so I wanted to do a video on this puzzle. This has a couple of things I wanted to point out. First of all, once in a while you can solve individual cells, and so I'll show you how to do that. And then you see a lot of twins. We see triplets fairly often, not as often as twins. But this puzzle actually has quadruplets in it, and you could potentially have quintuplets and sextuplets, and I'll show you that in just a minute. But this one has quadruplets, and those are fairly rare. I did see another set of quadruplets in another puzzle from this volume. But I'll show it to you here. So let's just look at that right now. We've got a 3, 4, 7, 9 right here, and in this square we've got a 1 and an 8 outside of this row, but nothing else. So we don't have any of these 4 numbers here yet. So this can be 3, 4, 7, 9. So those are quadruplets right there. We could have, potentially, in puzzles, we could have quintuplets and sextuplets, which are five numbers and 6 numbers. We can't really have septuplets, octuplets, or nontuplets, which are 7, 8, and 9. And I'll show you why. As soon as you have, if we had 6 numbers all filled in here and no numbers here, we'd have sextuplets. But as soon as you get 7 numbers, you're already spilling into this square. So 7, 8, and 9, 7s, 8s, and 9s aren't possible as far as twins and so forth. So you could have 5 or 6 here that would help you solve a square. So here we've got quadruplets. Right down here we potentially could have quadruplets, 1, 5, 6, 9, but we have a 6 there, so those aren't quadruplets. So let's take a look at this. We can't solve any of these 4 numbers that we found here, the 3, 4, 7, and 9, but one thing that will do when you find quadruplets is you only have 2 numbers left. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 and 6 fit up here because 3, 4, 7, and 9 fit down here. We can actually solve those because there's a 6 there. So we can put those in right away. And we've only got 1 and 8 left here. We've got an 8 there, so we can put the 1 in and an 8 here. Now we could have found that 8 and the 1 independently. The 8, we got an 8 here and an 8 here, so we knew that was an 8. We've also got 1s here and a 1 here, so we know that's a 1, and therefore we know that's a 1 there, up in the corner. But we figured those out. There's a couple different ways we could figure those out, in other words. Okay. Now I wanted to show you a technique called the individual cell solution, or solving an individual cell. You notice this cell right here. just all by itself, there are 8 of the 9 numbers already canceled out, so to speak. We've got a 1 here, a 2 here, 3, 4, 5, 6. There's no 6 here or here or here. And then we got a 7, 8, and 9 there. So we know that's a 6. And I'm not going to fill that in quite yet because I want to show you one other thing. But I wanted to point out that is an individual cell that you can solve all by itself. Okay, we also have an L pattern here, and we've got a 2 and a 3 right here, so we know that these are 2, 3 twins, and so therefore these are 5, 6 twins. And as I said a minute ago, this is a 6 here, so I'll just put that in, and therefore we know that's a 5. This could be a 5 here, because we've got a 5 here and a 5 here. But we know these are 2, 3 twins because of this L pattern here and the 2, 3 here. Okay. Another thing we could probably do right now is look at this bottom row here. We've got 5 of the numbers. 1, 2, let's see what's missing. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 3, 4, 7, and 8 that are missing on this bottom row, and you've got a 7 and 8 here and a 7 and 8 here, so we know that these have to be 3 4s, and there's a 4 there, so we can fill those in. Then we got a 7 8 here, we've got an 8 there, so we can fill that 7 in and this 8. Now there's some twins right here, and I'm just going through a few techniques we can use to help fill in some of the numbers. We haven't even gone through sections yet. We've got a 2 here and a 2 here, so one of these is a 2. We've also got 6s, so we know these are 2 6 twins right here. Let's see, we've got a 4 and a 4 here, so we know one of these is a 4. There's a 4 there, so one of these is a 4. We've got a 5 here and an 8 here, so we know these are 5 8 twins because these are 2 6 twins, so we've kind of eliminated those cells for any other numbers. So we got 4 5 and 8 here, and we got a 5 and an 8 here already. So we know that's a 4. So now we have 2 6 twins and 5 8 twins. We can look at these 2 rows and see if we can solve any more numbers on them. You know, when you first look at them, it looks like we've only got 3 numbers and we'd have to find 6 of them, but because of these twins, 2 6 twins, 5 8 twins, we only know we're only missing 4 numbers. So let's look at that. We've got 1 2 3 4 5 6 7 8 9. 1 5 7 9. We've got a 5 there, so 1 7 9 1 7 9. There's a 5 9, so that's a 1 7, and there's a 1 7, so that's 5 9. So we can't solve any of those. Let's look at this row right here. We know we've got 5 8 twins here, so we're missing 1 2 3 4 5 6 7 8 9 9. 1 3 7 9. Let's see if we can solve any of those. We got a 7 here, so 1 3 9. We got a 3 9 here, so that's 1 7. Oh, we got twins right there. These are 1 7 twins. Okay. So we know these are what is it, 5 9? 5 9s? Yeah, we've got a 5 and a 9 here, so we know these are 5 9 twins. Okay, so we got 1 7s here and 5 9s here. So it looks like we can't solve any of these at this point. All right, so let's just go through sections now. Now that we've filled in a bunch of numbers using these kind of more unique techniques that we don't usually use. Okay, 1, 1, 1, 1, 1, 1, oops, 1, 1, okay. Twos, we know these are 2, 3 twins here. 2, 2, 2. Okay, so we got 2 here, ghost 2's here, so one of these is a 2. Let's see. Any of those could be a 2. We got a 2 and a 2 there, so 2. Got a 2 here. We know one of these is a 2. So, okay, no 2's. 3, 3, 3, 3. One of these is a 3. 3, 3, 3, 3. 4, 4. So 4's. 4, 4, 4. 4 there. Any of those could be a 4. 5's. 5, 5, there's a 5 there and a 5 there, so one of these is a 5. 5, oops, 5, 5. Okay, so we got 5, 8 twins there and a 5 there, so we know, and there's a 5 here, so we know this is a 5. Okay, 6, let's see, 5. So one of these now a 5. Okay, 6's. 6, 6. Got a 6 there, so one of these is a 6. 6, 6, 6, 6. So there's a 6 right there. 6, 6. And 6, 6, 6. Okay, 7's. 7, 7, 7, 7, 7, 7, and 7, 7. So yeah, 1, 7 twins there. 7 and 7. Okay, 8's. 8, 8. So we got 4, 8 twins there. 8. One of those is an 8. So any of these could be an 8. And then 8, 8, 8. Okay. So we know, because of these 8's, we know one of these is an 8. And because of these 8's, we know one of these is an 8. So because of double row elimination, we know that one of these 3 has to be an 8, and there's an 8 here already, so it's one of these 2 right here. Okay, 9's. 9, 9, 9, 9. See, 9, 9, 9, 9. 9. Okay, there's a 9. So one of these has to be a 9. 9. Okay. All right. We know these are 4, 8 twins. 1 7's, 2 3's. What do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 9 twins there, and there's a 9, so we can fill those in. Okay, so we got a 9, 9. One of these is a 9, there's a 9 there. We got 9, 9, so that's a 9. Okay, now we got 9, 9, so there's a 9 there. And one of these has to be a 9, so there's a 9. Okay. I think we got all our 9s because we found this 9 right here. Now we got 4, 8 here and 1, 5, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 and 5, which we can't solve, and 4, 8, 1, 7. Alright, I think we had a number here we could probably fill in. Let's see. We got 5, 8 here. 5, 8, 5, 8, 2, 6. Let's see what's left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 and 7. No, we can't solve those yet. Let's look at this one again. Got 5, 8 twins here, so we got a 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 3, and 7. 7, 1, 7. 1, 7. Still can't solve those. Okay, let's look at a couple of more rows and columns that don't have many numbers missing. Let's just go through them. There's a 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 6, 7. There's a 2, 3, 4, 6, 7. 3, 4, 7. 2, 6, so 3, 4, 7 there. 2, 3, 4, 6, 7. 2, 3, 4, 6, 7, 2, 6, 7s, and 2, 3. Let's look at this row right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, and 7 are missing. So 3, 7. There's a 3, 2, 7, and 2, 3. Can't solve those. Let's look at this row. 1, 2, 3, 4, 5, 7, 8. 3, 4, 5, 7, 8. We got 3, 4, 5, 7, 8. 4, oh, that's right, 4, 8. Okay. So 3, 4, 5, 7, 8. 4, 5, 7, 8. 3, 5, 7, 8. 3, 5, 7, 8. 3, 4, 5, 7, 8. So 3, 4, 7, 8. 3, 4, 5, 7, 8. 3, 4, 7. Can't do anything with that. Let's look at these rows only have 3 numbers filled in so far. We know these are, let's look at some columns. 2, 3 twins, 1, 5 twins, 4, 8 twins, 1, 7 twins. We got 2, 6, and 5, 8 twins there. Oh, here's a number we could fill in. There's a 2. 1, 2, 3, 4, 6, 7, 8, 9. Okay, 2. And that should find, we got a 2 and a 2 here. 2, 2, so that's a 2. Okay. Let's see if we can fill in any other 2s. 2, no. No, okay. Let's look at that row now because I put that 2 in. 1, 4, 5, 7, 8. 1, 4, 5, 7, 8. There's a 7, there's a 4, 8. 1, 4, 5, 7, 8. So that's a 1, 5. 1, 4, 5, 7, 8. 1, 4, 5, 7, 8. 1, 4, 7, 8. So 1, 4, 7. 1, 4, 5, 7, 8. 5, 7. Okay, can't do much with that yet. We filled in a few numbers. Let's go through the sections one more time. 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2. Okay, 3s. 3, 3, 3, 3, 3. Okay, 4s. 4, 4, 4, 5s. Let's see, 5, 5, 5. Okay, we've got a 5 here and a 5 here, so one of these is a 5. A 5 here and a 5 here, so one of these is a 5. So we know one of these has to be a 5 because of double row elimination. So we got 5s there. Do we have another number that that only fits there? Don't see one right now, but we'll remember 5s there. 5s. Okay, 5, 5, 5. 6s. 6, 6, 6. 6, 6, 6. 6, 6, 6. Okay, 7s. 7, 7, 7, 7, 7, 7, 7, 7, 7, 8s, 8, 8. Okay, one of these is an 8, so we got 5s here and 8s here. Okay, we got 5, 8 twins there. Okay, 8s and 9s. I think we have all our 9s. Yeah, we have all our 9s. Let's see. Let's look through these columns here one more time. Well, instead of that, let's look at squares and solve for squares. We got 2 3s there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2, 6, 7. Okay, let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 4, 7. And let's look at this one. We've got 1 5s and 4 8s. Oh, here's a 3 that I missed before. Okay, we've got 3 here and 3 here, so that has to be a 3. Okay, so now we have 3's missing here. Okay, 3's, and 3's. Okay, alright, so 1, 2, 3, 4. And I think, yeah, this is where we have the 5s, because we have a 5 goes here and here, so we know one of these was a 5, so we know that's a 5. And because of that 5, we can fill in these 5 8s here. And we have an 8, 8, 8. Let's see, 8. Oh yeah, okay. I knew there was double 8s here. So we have 8s there. So one of these is an 8. We have 8s here, so one of these is an 8. So we know one of these is an 8. There's an 8 there, so that has to be an 8. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 and 7 missing. There's a 7 there, so 4, 7. Okay. Now we have a 7, 7, 7. Okay, we know this is a 7 because 7, 7. One of these is a 7, and one of these is a 7. So that's double column elimination there on the 7, so there's a 7 there. Okay, now we got 3, 4 left here, and we've got 2, 3 here. So if this, one of these is a 3, we have ghost 3s there, so we know that's a 2 and that's a 3. Okay, so we have 3 4s. What do we have here? We have 2, 6, and 7, I believe. 2, 6, 7. We have a 2 there now, so that's a 2. 6, 7, there's a 7 there. Okay, 3 4s. So we still have our 4 8s here and our 1 5s and 1 7s here. We have a 2 6 here. There's a 6. So we can fill those in now. Okay, we got 1 7s here and 1 7s here and 1 3 7s here. Let's see, so we have 3s here, 3 4, and 3s here. So we know one of these is a 3, and we've got a 3 there, so that's a 3. That's using double column elimination again. And what are we missing here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 there. So we have a 5, 5, 5. So that's a 5. Okay, now we can start really finishing this puzzle here. Let's see, look at this row here. 1, 2, 3, 4, 5, 6, 7, 8. 1 8 missing there. One of these is a 7, 1 and 7. So one of these has to be a 1, so that can't be a 1, so that's an 8. Okay. And let's look at this. We've got a few loner cells now. Let's look at some of those. We've got a loner cell here. 2 6 5 1 3, 2 6 5 1 3. So this number isn't in here yet, and so we've got identical twins right here and here. And these were 4 8 twins, so I know that's a 4. So this is a 4 also. Okay, let's look at these loner cells right here. 2 9 6 1. 2 9 6. Okay, there's a 1 there. It wasn't there yet, so we know that's a 1. Okay, now we can fill in these 1 7s because of this right here. 1 7 right there. What do we have left here? 3 and 7. 1 2 3 4 5 6 7 8 9. There's a 3. So we got 7 and 3. We have 3 and 4 here, and there's a 3. What do we have here? 7, 8, 9. 7 and 8. There's an 8. And we've got a 1 missing there. And that's it. We've finished it. So we found the quadruplets right off. That helped us find these 5 and 6 twins here. And then we found this L pattern, which gave us these 2 3 twins. We solved this individual cell right here just by finding all the other numbers but 6, solving an individual cell. And then we used twins down here, the 2 6 and 5 8 twins, and a few other combinations of techniques to solve this diabolical puzzle. Well, thanks for watching, and I'll see you again soon.